In this video, I'm going to go through some vector addition problems. So just as a review, when we talk about a vector, we're talking about a quantity that has both magnitude and direction. And on paper, we can indicate the direction with an arrow. So let me give you an example. I'm going to start off with this velocity vector, 4 meters per second. And I want to add it to a 3 meter per second vector. And this would be really easy because they're in the same direction. So you probably could guess that the sum of these two would be 7 meters per second. And just as an example, we could think of a train, like let's say you were in a train, and the train is moving to the right at 4 meters per second, and you're inside the train, and you are moving to the right 3 meters per second. And so from the frame of reference of someone at the train station looking at you, you would be moving at 7 meters per second, because not only is the train moving to the right, but you're moving to the right in the train. Okay. When we represent a vector with a letter, sometimes you'll notice an arrow on top, and that just indicates that it is a vector. So this right here would be vector A plus vector B. Okay. Now, what if you have a vector in the other direction? If you add a vector in the other, if we flipped one of those vectors into the other direction. So this velocity vector is to the right, and let's say you're adding it to a 3 meter per second vector, but it is to the left. What happens in that case? So then it's going to cancel out, not completely, but 4 minus 3, you're going to subtract it, so you're going to end up with 1 meter per second of velocity there. So this would be like if you were in that same, let's say you were in that same train, and the train is going to the right 4 meters per second, but this time you're moving to the left 3 meters per second. So from someone in the train station looking at you, it would look like you're moving to the right at 1 meter per second. Now let's take a look at another situation where you have a vector. Let's say you have a vector to the right 4 meters per second, and you have another velocity vector. It's going perpendicular to that 3 meters per second. Okay. So when you add vectors, you cannot just add those two numbers because they have a direction. And so what we're doing here is we're using what's called the tip to tail method. So you draw the first vector and you place the second vector where the tail is touching the tip of the first one, and then you connect the beginning to the end, and this would be the sum of those two vectors. You'll notice this is a right triangle, so we could do Pythagorean theorem. Okay, so 3 squared plus 4 squared is, we have 9 plus 16 gives 25, and square root that, and we get 5 meters per second. So the sum of these two vectors is 5 meters per second. You can also calculate the angle right here as well using a little trig. Okay, so tan theta is equal to the opposite, 3 over 4. And then if you do the inverse tangent on your calculator, you would get approximately 37 degrees. Okay. So in everyday life or in the real world, when might this occur? So you could have a plane flying, and there could be a wind pushing it sideways. You could also even have, let's say, a lake, and you're in a boat. So here is, you have your boat, and you're trying to go across the river, and then you also have the river is flowing downstream, and so you're not going to end up directly over here. You're actually going to end up somewhere over here, and you can calculate this. If you know the numbers, you're going to actually end up going this way. You can even calculate the angles using trig. Besides the tip to tail method, another way to calculate to add vectors is the vector component method. And so let's say we have a vector going this way and a vector going this way, and let's say these are force vectors, 3 newtons and 5 newtons, and let's say my positive x is this direction, positive y is that direction. Okay, and let's say this is a vector A, and this is vector, let's say this is vector B. Okay, so what we do is we break this into components. And so this would be the x component, and that would be the y component. And we can use a little bit of trig here to calculate those components. So let's say that this was 40 degrees. Okay, so cosine 40 is equal to x, the adjacent over the hypotenuse. So x equals 5 cosine 40, which is going to be 3.8. And I'm going to put a negative because it's in the negative direction. And then sine 40 degrees is equal to y over the hypotenuse. And so y is equal to 5 sine 40, which is 3.2. Okay, so I'm rounding these numbers here. Okay, so now I'm going to create a table. Here's my table. And I'm going to have my x component, my y component. So these are my components. And this is my vector A, vector B, and this is my resultant, or I'm going to call it the sum. Okay, the resultant is just the sum of these vectors. So let's start with A. So A has a positive 3 Newton vector to the right, and then it doesn't have any, there's no components vertically, so it's just going to be 0. Now B has a component, an x component of negative 3.8 to the left, so it's negative. And then in the y direction, it has a component of 3.2. So it has these two components. And then now I'm just going to add these up. So 3 minus 3.8 is negative 0.8. And then 0 plus 3.2 is just 3.2. Okay. So I could, what I could do is I could use the tip to tail method to add these two vectors. So it would look something like this. And then that's the vector B, and then of A would be vector A, would look something like this, and then I would end up with a component, with a sum, a resultant, okay, a resultant that would look something like this. Okay. Or I could just use what I calculated over here, which is that these two, if you add them up, you would get a vector, a resultant with these components. So I have 0.8, so it's going to be, this is negative 0.8 newtons, and then this is going to be 3.2, go up 3.2, 3.2, and then so you're going to get the same resultant, okay? So you can use the tip to tail, or you can use the vector component. Now we're going to take a look at one more method called the vector notation. Okay, so in the vector notation here, I'm going to first indicate my positive direction. And I have these two vectors. I have vector A, and I also have vector B. And I'm gonna give you what the components are. So let's say you know what the components are. So this is 6. And it's 30 degrees, and this side is going to be 6. We don't know the y, we'll call this y A, we don't know that component. And vector B, we know that this side is going to be the x component is 3, but we don't know the y component. Okay. So you just have the angle, and you have the angle, and you have one of the sides. So we want to add these two up. Okay, so we want to add these two. We want to add A. Well, what would be the sum of A vector plus vector B? That's what we're looking for. Okay, and of course you could just use the tip to tail method. But if you want to get some numbers, then you're going to have to do a little calculation here. So I'm going to use some trig here. So tan 30 equals YA, the opposite, over the adjacent. So YA is approximately 3.5. Okay. And then for YB, I need to calculate that too. So tan 60 is YB divided by 3. And so YB is equal to 5.2. All right. So here's the vector notation. So I'm going to write the x component value, which is 6. and then we're going to write this symbol called I hat, and this is just a vector length of 1, and it indicates direction, and this is along the, you can think of it as the x direction, plus 3.5 j hat, and this would be along the y direction. Once again, this is a vector length of 1. So this would be able to give you enough information to figure out the vector for vector A, how large, what the quantity of vector A is. Okay, so vector B would be negative 3 I hat because it's in the negative direction, plus 5.2 j hat. And so if we wanted to add up, if we wanted to add vector A plus vector B, the real nice thing about this is you can just take this 6 I hat plus 3.5 j hat plus minus 3 I hat plus 5.2 j hat, and then you just add up all the I hats and all the j hats coefficients, right? So you have 6 and minus 3, so that's just going to be 3 I hat, and then you have 3.5 and 5.2, you just add those coefficients up, so you get 8.7 j hat, and using these numbers you can figure out what the resultant vector is. So we have a positive 3 along the x, we have a positive 8.7, 3 and 8.7 along the y, and your resultant from start to end will be right there, and you can use your Pythagorean theorem to find this side. You can also use trig to find this angle as well.